All right, so I just got in today, so I'm like wicked tired, so I apologize if I feel or seem a little off. But we'll just dive right in. So this talk is called Tracing Fast and Slow. My name is Lynn Root, and I am a site reliability engineer for Spotify. I've been at Spotify for about 5 years now. I also do a lot of internal open source evangelism, helping people open source their own projects and contribute and whatnot. And as a lot of you do know me, I do a lot of PyLadies work as well. I brought some stickers. There were already plenty of stickers over there, but there's plenty more now. So if you want some, I think I got some rainbow PyLadies stickers and some other ones. You should check them out. So quick question. Has anyone read or heard of the Site Reliability Engineering book from O'Reilly? There's a couple, yeah. It's known as the Google SRE book. And it's basically, the too long didn't read of that book is use distributed tracing. And so with the prevalence of microservices, whether you own them or you don't own them, you might not know where the requests HTTP requests goes through from one service to another. But it's imperative to understand where your code fits into the grand scheme of things and how it all operates. So there are three main needs for tracing a system. There's performance debugging, there's capacity planning, and problem diagnosis, although it can help with many other things as well. And so this talk might have a slight focus on performance debugging. These techniques certainly can be applicable to other needs as well. So we'll start with an overview of what tracing is and what problems we want to try and diagnose with it. We'll also talk about some general types of tracing we can use and what key things to think about when scaling up to larger distributed systems. The inspiration of this talk stemmed from me trying to improve performance of one of my team's services, which kind of implies that we don't really do tracing at Spotify. So I'll run through some questions to ask and some approaches to take in diagnosing and fixing a service's bottleneck. And then finally, I'll wrap up with some tracing solutions for profiling performance. And hopefully, at the end of all this, there will still be some time for questions. So in the simplest of terms, a trace follows the complete workflow from start of a transaction or request to its end, including components that it flows through. So for a very simple web application, it's pretty easy to understand the workflow of a request. But then you add some databases, separate front end from the back end, throw in some caching, maybe have a few external API calls, all behind a load balancer, scale it up to tens, hundreds, thousands of times, then it gets a bit more complicated to understand how the workflow is. So historically, we've been quite focused on machine-centric metrics, including system-level metrics like CPU, disk space, memory, as well as app-level metrics like requests per second, or response latency, or database writes. Following and understanding these metrics are quite important, but there is no view into a service's dependencies or its dependence. It's also not possible to get a view of a complete flow of a request, nor develop an understanding of how one's service performs at scale. So a workflow-centric approach allows us to understand relationships of components within an entire system. We can follow a request from beginning to end to understand the bottlenecks, hone in on anomalistic paths, and figure out where we need to add more resources. So when looking at a simplified system where we have a load balancer, a front end, back end, database, maybe some external dependencies to a third-party API, when we have redundant systems, it can be particularly confusing to follow a request. So then how do we debug a problem of a rare workflow? How do we know which component of the system is the bottleneck? Which function call is taken longest, or is there another app on my host causing distortion of machine-centric performance metrics, like the noisy neighbors concern? With so many paths that a request can take, with a potential issue at every node and at every edge, this can be mind-numbingly difficult if we continue to be sort of machine-centric. So end-to-end tracing allows us to get a better picture to address these concerns. Mind you, we don't really trace at Spotify, but it'd be quite helpful. These are super secret numbers. Looking at magnitudes of what we're operating at Spotify, this was actually last year, so we're even bigger now. You can kind of see where tracing probably would help us out. So why trace? Real quickly, there are many reasons to trace a system. The one that inspired this talk is performance analysis. This is trying to understand what happens at the 50th or the 75th percentile, the steady state problems. This will also help identify latencies, resource usages, and other performance issues. We're also able to answer questions like, did this particular deploy of this service have an effect on latency of the whole system? Tracing can also clue us in on anomalistic request flow, basically the 99.9 percentile. The issues can still be related to performance, but they often help identify us with correctness or component failures or timeouts that we wouldn't normally see. Profiling is very similar to the first, but here we're just interested in a particular component or an aspect of the system. We don't necessarily care about the full workflow. We can also answer the question of what a particular component depends on, what depends on it, and particularly useful, which is particularly useful for complex systems. So with dependents identified, we can attribute particularly expensive work. So component A adds significant workload with disk writes to component B, which can then be helpful when attributing costs to teams or service owners or component owners, where component A forces component B to spend a lot more money on resources. And finally, we're able to create models of our systems that allow us to ask what-if questions, like what would happen if component A, what would happen to component A if we did a disaster recovery test on component B. So there are various approaches to tracing, of which I'll only highlight 3 common ones. The first is manual and is also very simplistic, where you're generating your own trace IDs and then adding them to your logs. And there are simple things that can be done that can be added to a web service, especially one that does not have dependent or depending components that you don't necessarily have access to. You won't get any pretty visualizations or help with centralized collection beyond how you typically handle your logs, but it still can provide a lot of insight. So this is an example of a Flask route and a decorator. Here you can simply add a UUID to each request received as a header, and then log at particular points of interest, like beginning and end of handling requests, and any other in-between component or function calls, and then propagate those headers as you can. This is exactly what I ended up doing with my own service, which made me wish for a better way. So hence this talk. And I typically do a lot of conference-driven development myself. So we are starting to do tracing now, finally, at Spotify, finally. If your app is behind like Nginx that you're able to edit, you can turn on its ability to stamp each request with a xRequest ID header, as you can see with the add header and set header. You can also very simply add that request ID to Nginx logs with the log format of trace and add that request ID. Another approach, black box tracing, is basically tracing with no instrumentation across the components. It tries to infer workflows and relationships by correlating variables and timing within already defined log messages. So from there, relationship inference is done via statistical regression analysis. It's easiest with centralized logging, and if there's somewhat standardized schema to those log messages that contain like an ID and a timestamp. It's particularly useful when instrumenting an entire system is too cumbersome, like too much coordination among all the engineers, or you can't otherwise instrument components that you don't own. So as such, it's quite portable, and it's very little to no like overhead. But it does require a lot of data points in order to correctly infer relationships. It also lacks accuracy with absence of instrumenting components themselves, as well as the ability to attribute causality with asynchronous behavior and concurrency. So another approach to black box tracing can be done through like network tapping itself with the use of like sflow or NFDUP or IP table packet data, which I'm sure a few of our governments are very familiar with themselves. Final common type of tracing is through metadata propagation. And this is the approach that was made by popular by Google's research paper on Dapper. So components are instrumented to at a particular trace point to follow causality between functions, components, and systems, or even with common RPC libraries like gRPC that will automatically add metadata to each call. So metadata that is tracked includes a trace ID, which represents one single trace or a workflow, and a span ID for every point in a particular trace, like requests sent from the client, requests received by server responds, plus a span start and end time. So this approach is best when the system itself is designed with tracing in mind, but no one actually does that, I guess. No one has the foresight. But it avoids the guesswork of inferring causal relationships. However, it can add a bit of overhead to response time and to throughput. So the use of sampling traces limits the burden on system and data point storage. So sampling between 0.01% and 10% of requests is deemed plenty, or usually plenty, to understand a system's performance. When starting tracing, when starting to have many microservices and scaling out with more resources, there are a few points in mind when instrumenting a system, particularly with metadata propagation, the approach that's most common. So in terms of what to keep in mind, and I'll go into more detail about each. We want to know what relationships to track, essentially how to follow a trace and what is considered a part of the workflow. How they are tracked, constructing metadata to track causal relationships is particularly difficult. There are a few approaches, each with their own fortes and drawbacks. And then how to reduce overhead of tracking. One approach chooses, sorry, the approach one chooses in sampling is largely defined by what questions that you're trying to answer with your tracing. There may not be, it might not be a clear answer, but it might become clear at the end. But then there also might be some penalties for each approach that one might take. And then finally, how to visualize. The visualizations needed will also be informed by what you're trying to answer with tracing. So the first part, what to track. When looking within a request, it can take 2 points of views, either the submitter point of view or the trigger point of view. The submitter point of view, it follows or focuses on one complete request and doesn't take into account if part of that request is caused by another request or action. So for instance, evicting cache that was actually triggered by request 2 is still attributed to request 1 since its data comes from request 1. On the other hand, the trigger point of view, it focuses on the trigger that initiates the action, where in the same example, request 2 evicts the cache from request 1, and therefore the eviction is included in request 2's trace. Choosing which to follow depends on the answers that you're trying to look for. For instance, it doesn't matter which approach is chosen for performance profiling. But following trigger causality will help detect anomalies by showing critical paths. Next up is how to track, or what is essentially needed in your metadata. What this boils down to is that it can be difficult to reliably track causal relationships within a distributed system. The sheer nature of a distributed system implies issues with ordering events and tracing that happens across many hosts. There may not be a global synchronized clock available, so care must be taken in deciding what goes into crafting the metadata that is threaded through an end-to-end trace. So using a random ID like UUID or request ID header will identify causally related activity, but then tracing implementations must then use an external clock to collate those traces. In the absence of a global synchronized clock, or to avoid issues such as clock skew, looking at network send and receive messages can be used to construct causal relationships, because you can't actually receive a message before it's sent. A lot of tracing implications do use this simplistic approach. However, this approach does lack in resiliency, as there is a potential for data loss from external systems or inability to add trace points to components owned by others. So tracing systems can also add a timestamp derived from a local logical clock to the workflow ID, where it isn't exactly the local system timestamp, but either a counter or sort of randomized timestamp that is paired with the trace message as it flows through those components. And so with this approach, we don't need the tracing system to spend time on ordering the traces it collects, since it's explicit in the clock data, but parallelization and concurrency can complicate understanding these relationships. And then one can also add the previous trace points that have been executed within the metadata to understand all the forks and joins, like from concurrency. It also allows immediate availability of tracing data as soon as the workflow ends, as there is no need to spend time on trying to establish the order of causal relationships. But as you can imagine, the metadata will only grow in size as it follows a workflow, adding to that request payload. So it basically boils down to this. If you really care about payload of requests, then a simple unique ID is your go-to. But that's at the expense of needing to infer relationships. You can add a timestamp of sorts to help establish explicit causal relationships, but then you're susceptible to potential ordering issues of traces if data is lost. You might add previously executed trace points to avoid that data loss and to understand the forks and joins of a trace, and then also gain the immediate availability of the trace data, but then you suffer in payload size. And then there's also the fact that there are no open source tracing systems that actually implement this last one. So end-to-end tracing will have an effect on runtime and on storage overhead, no matter what you choose. For instance, if Google were to trace all their web searches, despite its intelligent tracing implementation, it would impose a 1.5% throughput penalty and add 16% to the response time. So I won't go into too much detail, but there are essentially three basic approaches to sampling. There's the head-based approach, which will make a random sampling decision at the start of a workflow and then follow it all the way through to completion. There is the tail-based, which will make the sampling decision at the end of the workflow, implying some caching going on. Tail-based sampling needs to be a bit more intelligent, but is particularly useful for tracing anomalistic behavior. And then finally, unitary sampling, where the sampling decision is made at the trace point itself, and therefore prevents the construction of a full workflow. So head-based is the simplest and ideal for performance profiling, and both head-based and unitary are often seen in tracing, current tracing system implementations. And I'm not quite sure if there's anything that implements tail-based systems quite yet. And then what visualizations do you choose to look at definitely depends upon what you're trying to figure out. So there's Gantt charts. They're quite popular and definitely appealing, but it only shows requests from a single trace. I'm sure you've seen this sort of type when you look at your network tab of your browser dev tool. When trying to get a sense of where the system's bottlenecks are, a request flow graph it will show workflows as they're executed. And unlike Gantt charts, we can aggregate information of multiple requests in the same workflow. Another useful representation is a calling context tree in order to visualize multiple requests of different workflows. This reveals valid and invalid paths for requests that they can take, which is best for creating sort of a general understanding of system behavior. So what the takeaway here is there's a few things we need to consider when we trace a system. You should have an understanding of what you're trying to do and what questions you're trying to answer. Certainly there might be other realizations and questions that come from tracing. So for example, with Dapper, Google is able to audit systems for security, asserting only authorized components are talking to sensitive services. But without understanding what you're trying to figure out, you may end up approaching your instrumenting incorrectly. So the answer to this question will help identify how to approach the causality, whether from a trigger point view or a submitter point of view. Another important question, how much time can you put into instrumenting your system, or can you even instrument all parts? This will inform the approach you can use to tracing, be it black box or not. If you can instrument all the things, then it becomes a question of what data should you propagate through an entire flow. And then finally, how much of the flows do you want to understand? Do you want to understand all requests? If you do, then you have to be prepared to take a performance penalty on the service itself, and then have fun storing all that data. Or is a percentage of flows okay? And if so, then how to approach sampling is in your answer of what you want to know. So for understanding performance, head-based sampling is fine. You also have to think about whether or not you want to capture the full flow of the requests, or if you want to focus on a subset of the system. This will also affect your sampling approach, be it unitary or not. And I'm going to try and answer those questions for you, because I'm up here. So with performance or steady state problems, you want to try and preserve the trigger causality rather than the submitter, as it will show critical path to that bottleneck. Head-based sampling is fine, as we don't need intelligent sampling. And even with low sampling rates, we're able to get a good idea of where our problem lies, since we only care about like the 50th or 75th percentile. And finally, a request flow graph here is ideal, since we don't care about anomalistic behavior. We want information of like the bigger picture rather than looking into particular individual workflows. And most often, once you're tracing a system, the problem will reveal itself, as will the solution, but not always. So I do have a few questions to ask yourself with figuring out how to improve a service's performance. First question is, like, are you making multiple requests to the same service? Round-trip network calls are quite expensive, so perhaps you can set up a way to batch them. Perhaps your service doesn't need to be synchronous, or it unnecessarily blocks. For example, if you're like this big social network site, can you grab a user's profile photo at the same time that you try and pull their timeline, at the same time that you try and pull their messages, rather than going one after the other? Is the same data being repeatedly requested but not cached? Or are you caching too much or not the right data? Is the expiration too high or too low? What about your site's assets? Could they be ordered better to improve loading time? Can you minimize the amount of inline scripts? Maybe your scripts can be async. Are there a lot of distinct domain lookups that add time to DNS responses? How about decreasing the number of actual files referenced or minify and compress them? A bunch of things can be done in the front end to help performance. Perhaps you can use chunked encoding when returning large amounts of data, or you're otherwise able to have servers produce elements of response as they are needed, rather than trying to produce all elements as fast as possible. So now on to some frameworks and systems and services. So open tracing has been around for a little while. It's an open standard for distributed tracing, and it allows developers to instrument their code without vendor lock-in. And they do this by standardizing trace-spanned APIs. One criticism of open tracing is that they don't prescribe a way to implement more intelligent sampling other than the symbol percentage and setting a priority. There's also a lack of standardizations for how to track relationships, whether submitter or trigger-based. It's pretty much just all submitter-based. And it's just a standardization for managing the span itself. But mind you, it's still a pretty young specification that is evolving and developing currently. Open Census was just released at the beginning of this year. It's an open source project from Google. And it defines itself more as an observability framework, and so it's not just tracing. There is a bit of overlap between open tracing and open census in terms of use case and purpose, but they're different in terms of API philosophy and approach. So both open tracing and open census defines an API for working with traces and spans, and both include language-specific client libraries. Although one noticeable difference is that open census publishes a standard library for each language, as opposed to clients being available for open tracing across various repos and owners. So it's all centralized with open census. Open census is a bit broader in scope. It not only defines an API for tracing, but it also includes a defined API for the collection and exporting of metrics. A subtle but a significant difference is that open tracing encourages the use of its tracing API for logging and for metrics and tag propagation in addition to tracing, basically sort of like a one-size-fits-all API. So for example, you'd be forced to use the concept of tracing spans within logging. Open Census, on the other hand, decouples those purposes and has separate APIs for each. Allows a bit more flexibility in terms of appropriateness for different use cases and dependency management. There are a few self-hosted popular solutions that support both open tracing and open census in some fashion. Probably the most widely used is Zipkin, which comes from Twitter. Has implementations in Java, Go, JavaScript, Ruby, Scala, and has client libraries for a lot of other languages. The architecture setup is basically the instrumented app sends data out of band to a remote collector that accepts a few different transport mechanisms, including HTTP, Kafka, and Scribe. With propagating data from a service, all the current Python libraries only support HTTP. I don't think there's RPC support quite yet. And Zipkin does provide a very nice Gantt chart or waterfall chart of those individual traces. And you can see a view of dependencies, but it's only a tree with no information of latencies or status codes or anything else to help you. So this is PyZipkin, which one of their libraries is based. You need to define a transport mechanism, as I do here, and then it's just a simple post request. You can otherwise have Kafka or Scribe transport, but then it's just a simple context manager placed wherever you want to trace. Jaeger is another one. It's another self-hosted tracing system that supports open tracing specification. It comes from Uber. Rather than application or client library reporting to a remote collector, it reports to a local agent via UDP, who then sends out traces to a collector. So unlike Zipkin, which supports Cassandra, Elasticsearch, and MySQL, Jaeger only supports Cassandra for its storage, which can be difficult to work with. The UI is very similar to Zipkin with pretty waterfall graphs and a dependency tree, but again, nothing that can easily help aggregate performance information. The documentation is also horribly lacking, but they do have a decent tutorial to walk through. And their client library is a bit cringy. So this is, I guess, a trimmed example from the documentation, but you can kind of get the gist of what's going on here. Basically, you initialize a tracer that the open tracing Python library will use, and then create a span and child spans with a context manager. But then they use like time.sleep for yielding to IO loop, which was a bit of a head scratcher. Its documentation mentions support for monkey patching libraries, and when I hear monkey patching, I kind of want to run away. So their Python library is a little bit questionable. Honorable mentions, there's also AppDash, which is based on Zipkin and Google's Dapper. It does support the open tracing API, but not open census. And I'm not familiar with any other open source self-hosted tracing solution other than those three. But in case you don't want to host your own system, there's a few services out there that can help, that will happily take your money. There's Stackdriver Trace, which is from Google, not to be confused with Stackdriver Logging or Stackdriver Profile or other Stackdriver products that they have. So with the release of Open Census in the past year, Stackdriver has added Python support by way of the Open Census Python client library, which also includes gRPC support. When I first wrote this talk about a year ago, they only supported REST, so they've recently added gRPC. They also support Zipkin traces, where you can set up a Google-flavored Zipkin server, either on their infrastructure or on yours, and have it forward traces to Stackdriver. And they make it pretty easy. I was able to spin up a Docker image and view traces within like a couple of minutes. Annoyingly, they have a storage limit of 30 days, which is the same with their other Stackdriver products. And last criticism is about their UI. They have very simple plots of response times over the past few hours, and a list of all traces, which are automatically provided by the UI. However, if you have to make like manual analysis reports for each time period that you're interested in to get any fancy distribution graphs, so they're not automatically generated. What is nice is that you're able to view logs alongside a particular trace for added context. Amazon has a tracing service available called X-Ray, and I'm pretty excited about this one. It supports the Open Census API, but not Open Tracing. So within the last year, they added support for their SDK for Python, as well as Go and Ruby, which takes care of pushing metrics to like a local demonized collector. When I first looked at X-Ray, they only had first-class support for Node, Java, and .NET runtimes, essentially forcing other languages to interact with their external API and figure out how to handle reporting traces. What's nice about X-Ray, despite it being kind of proprietary, is that you're able to configure sampling rates based on service types like EC2 or Beanstalk or container services, or on different URL routes of your application, or on HTTP methods, or even just key value pairs that you define yourself. Another cool thing, you're able to send traces from outside of AWS environment to the X-Ray service. They've open sourced their daemon, which is the intermediary between the app instrumented with their SDK and the X-Ray backend. So you're able to set up the daemon elsewhere, whether like physical hosts or another cloud provider, but still make use of their X-Ray product. It also has the best of visualizations, in my opinion. While there is the typical waterfall chart, they also have request flow chart. They can see average latencies. They that's like captured traces per minute, and requests broken down by response status. A year ago when I gave this presentation, AWS lacked Python support and didn't support any open API, nor did they have a way to send metrics from the outside of AWS ecosystem. So I'm actually quite happy to see that they've developed this product a bit more, because it has the most flexibility in terms of sampling and the best visualizations compared to other options available. There's a couple of honorable mentions that do app performance measurement. And I have to be frank, I don't have any experience with any of these services in the problem space, but they certainly provide a lot of helpful tools across applications. In terms of open tracing versus open census, the first three only support the open tracing API, while Azure's product supports the open census API. Okay, so a quick opinionated wrap-up. If you run microservices, you should be tracing this. Otherwise, it's very difficult to understand an entire system's performance, anomalistic behavior, or resource usage, among many aspects. However, good luck with that. Whether you choose a self-hosted solution or a provided service, documentation is all around lacking. Granted, it's still very young space. Very much is growing around the open tracing and the open census standards as they're being developed and adopted. A year ago, language support for Python was lacking, but it's getting better as this area of engineering kind of grows up. But there's a lack of configuration for relationship tracking, for intelligent sampling, and available visualizations, particularly with the self-hosted solution space. But with these two open specifications, they can be influenced, or you can implement your own if you are so inclined. All right, that is it. Thank you so much.
Hello, Lynn. Thanks a lot for your speech, for the presentation. I have a little bit silly question, but it really interests me. Of course, none of us just born with the ability to code or to do some cool stuff as tracing. And what interests me a lot is how did you start this? Was it your own interest and then you started work with tracing the data, or you firstly had to do it for your work and then you started interested in it, and this become such an occupation and, as I can understand, hobby for you because you are so passionate about it. Thanks.
Are you asking about the interest in tracing, or in general engineering?
I think tracing as a part of your engineering.
Yeah, okay. Oh boy. Well, and actually, I mean, it was pretty simple in that one of our internal services that my team runs. My team is an infrastructure team for supporting the rest of Spotify engineers. And we have this little app that you can use to request hosts to deploy your applications on. And it's just you can ask for one host or 50 hosts or however many you need. And so this application was quite slow in that it would take 30 seconds to show you all the instances you do have already. And we got so many complaints. So I think one time I was just F it. And I just sat down for a weekend and started putting in print statements into the request logs, just to see how where the bottlenecks are. And I'm there's got to be a better way. And this is maybe about 2 years ago. And so within that time frame, tracing has started to really become a thing. It's still rather new, maybe a couple of years old, in terms of really becoming popular with large systems. So I mean, that's what kind of catapulted me into this. And now there's this whole team, it's called the observability team, that does metrics, but also taking on tracing, which I'm not a part of that team, but I'm I sit next to them, so I'm what's going on over here? Can we use this yet? So, I mean, that's how I got into it, is just literally, I had a slow service, and I hated the complaints from my users, and I wanted to shut them up.
Sorry, just a sec. I will pass you the mic, but a quick comment. I guess we could allow and even encourage questions not only about the topic of the speech, if you're okay with that,
Yeah.
but about the Lynn's career, about the Red Hat and the recent news, about the Lynn's actions on the PSF. You were in the board of directors of PSF, right?
Mm-hmm.
This is probably one of the most important person of Python world. So please feel free to ask her anything, okay?
Yes.
Yeah. And you were raising hand.
I'm blushing now.
Hi.
Hi.
So obviously tracing adds some overheads to a time of execution, and well, you mentioned a lot of frameworks and services that allow to do tracing, to enable it in our services, but do they provide an ability, to turn off tracing during some intense hours when we have a lot of requests and so on? And how common is it?
Yeah, that's a good question. I think more with the services rather than like the self-hosted solutions, it's easier to kind of like dial it up and dial it down as you need. In terms of like, you can turn it all off, the sampling all off for like some like X-ray and Stackdriver, and like when you do need. It's not intelligent in that you have to like go in manually and like maybe within the UI. It'd be nice to have that sort of like an intelligent kind of thing within the service itself. But yeah, I don't think within this, not much is available within the self-hosted sort of stuff. You could probably maybe code some like client-side code as sort of a not necessarily circuit breaker, but like if you reach a threshold, then you can like stop yourself. But still, like that's a lot of manual work on you still. So it's still kind of like growing up, and maybe you'd be willing to like contribute to those like open source libraries to add that. But yeah, there is that possibility, but you're essentially paying for it.
Yeah, and also one more question related to this. So I'm not too familiar with the technology, so maybe my question is not too smart. But anyway, so you can enable tracing by putting some how is it called in Java? It looks like annotations. Как вот эти собаки? Decorators. Yeah, I forgot the word. So you can place decorators, but can you enable tracing for some particular methods kind of on the fly? So you already have your Python interpreter running, and you kind of apply some agent. Well, I'm a bit familiar with Java, so I make I'm trying to apply similar thoughts from Java to Python. So can you attach some kind of instrumentational thing that can find your methods and apply tracing on the fly to these methods? Do you understand what I'm trying to ask?
I think so.
So I mean, can you not hard code what methods you want to sample, but kind of attach to already running application?
I don't think so. Yeah, I don't think Python can do it, but I feel like it's a New Relic or something can sort of hook into things that you don't really have to like instrument code. That just sort of, I don't. Yeah, that's it. So basically, I don't think there's a nice way to do it, if at all.
Okay. Yeah.
And there's strace, but. All right. Other questions? Yeah, one over there.
Thank you again for the presentation and the speech. I have a very not related question. Why Python? Why do you like Python and why you chose this language?
That's a fair question. So I feel like I have to give a little bit of my background story in general. I have a finance and econ degree, and I was in finance for a few years, and then I saw that there's like this financial engineering sort of graduate program, but you needed to know how to program before you could even apply to that program. So I took a course at Harvard. They have like this adult like extension school that you can just take any courses that you can pay for, essentially. And it was just like intro to CS. And they started you off with C. Can you still hear me? Am I good? All right, I'll just put this here. So for like the first like 8 weeks or so, I was programming in C, and it was a nightmare. And then I went to this like one like hackathon, and in San Francisco. It was like a science day thing. It was really cool. And there's this like PhD person that was like studying from the Large Hadron Collider, and he had all this like information. And he was like, "We'll just use Python." I'm like, "I don't know Python. I've never seen it." But then when I like looked at it and you start coding it, I'm like, "This is English. It's like this makes sense." So then I was just like, I'll just kind of start working in Python. I did my final project for the course in Python, and for some reason, like in that course, I like failed both midterms because C was hard, right? But because I did my final project and it was working in Python, they gave me like an A-. So I don't know how like that adds up in terms of a course grade. But yeah, so that's how I got into Python. And then like I was like, I still want to learn. So I just got. I conned other women to learn with me because I didn't want to be like alone, and so that was like the birth of like PyLadies, kind of. But yeah, that's Python is just easier to understand than C, and I was just like looking for an out, and so Python caught me.
One more question. What inspires you the most? One more unrelated question. Yes.
In general, or? In
general, yeah. For you, engineering, for your life, what's your source of inspiration and energy?
Inspiration comes from a lot smarter people than me, I feel like. I like going to conferences and seeing people speak about like, new things and like really difficult like concepts that I'm like, this sounds cool, but I have no idea what's going on. And so then I tried and like bring it back to work somehow. And unfortunately, that's like kind of like a lame answer, but essentially it's like the people around me that I can try and surround myself with are the people that I find inspiration from. Sorry.
Oh, that's great. Thank you.
Hi, Lynn. It's nice to meet you. Thank you for coming. My name is Ira, and I came from Moscow to meet you. Oh. So my question is, as like the founder of PyLadies, what's the main message you'd like PyLadies should bring to the world?
Ooh, that's a
and go.
Oh man. That's
okay, there can be two.
Let's see. The main message, to be honest, like I think I've always tried to show that like programming in Python is fun, and that it's like a thing to like a thing to be interested in and to pursue, not necessarily like let's get women into Python or let's get women into programming, but like no, let's find other nerds to like nerd out with and like learn together. And it just so happens that like a lot of them are like women. It's great to learn and to be in an environment where it's like predominantly women in terms of like workshops and you're learning something new. It's a little bit less stressful, a little bit less competitive, I find. But what I appreciate most is sort of the relationships that come out of that, and friendships, and like just the time spent. Because I like nerding out, but I just don't want to nerd out alone. So my message is basically I want PyLadies to encourage like how it's fun. It's not like, yeah, our mission is to like increase diversity, but like
through fun.
Yeah. Yeah.
Through fun in Python.
Yes.
Thank you. Question? Question? Oh, come on, guys.
So I guess this will be from me then. So we had a sort of like Hacktoberfest event with PyLadies lately. And my question is basically, how do you first started contributing to open source, and what are your advice maybe for, for wannabe contributors as myself?
I think a lot of people suggest find a project that you're interested in and want to help, or that you use and you have a problem with. But what happened with me was I happened upon a community of people that I liked and wanted to get to know. That was like the Django community, and in extension the PyLadies community. So my first contributions went to that. Because it was the people and not the project. They made me feel welcome and encouraged and inspired. So I felt that was more important than what I was trying to do. Because what I was trying to do was just trying to get experience, not necessarily like the project that I was on or something like that. So I think that would be one way to suggest going about contributing to open source is finding a group of people that you like and admire. You don't necessarily have to have a passion for the project, but a passion for the people, because that's what's going to keep bringing you back, I feel like. If you could have a project that you use every day and that they're just jerk maintainers and they don't appreciate any help that you want to give, and that's not quite nice. It's not going to give you a good experience. Yeah, so you can find these communities on I guess on Twitter and IRC, if that's even still around.
Oh, it is.
Okay, and I mean even within GitHub itself. But yeah, I hope that helps some.
Thanks. Oh, all right. So anybody? Any questions? All right then. Oh, so.
I have a bit sad question. Have you ever faced discrimination based on that you are a woman? I mean, kind of when you, for example, when you're applying to a job, you feel like people do not consider you as a candidate just because you're a woman, or some other cases.
I mean, yeah, I guess. It's hard to pinpoint because I'm a woman or because of a different personality type or something like that. But when you're the only woman in the room, it kind of feels that way. I haven't had issues in terms of interviewing and getting in the door, but it's the issues that come once you're inside the door that happens a lot. I found myself, not so much anymore, but I found myself getting run over in meetings, either interrupted or even just not even heard. I say something and then 5 minutes later someone else repeats it and they get credit for it. That happens to me a lot. What I've appreciated at work to combat that is some of the meetings that we have consist solely of Post-it notes in the beginning. So you write ideas on Post-it notes and put them up on the board, so that kind of anonymizes just a little bit and forces you to look at every kind of idea and approach straight on rather than attributing it to a person. So that has helped greatly, but it's still ongoing. I do find myself getting preferential treatment, I guess, because I am the one woman that's a lead at my company in terms of the level of engineering I'm at, which also feels weird. I just don't know what to do, I guess, in that case, or in both cases, it's kind of hard. Yeah, so yes, but I don't know how best to suggest going about counteracting those sorts of things. I mean, so many people talk about them. Nothing new. I can't say anything new or revolutionary to that, I guess.
Yeah, so, and one more question related to this. Do you have any observations about different countries, how the situation is different from country to country?
For like diversity, or
yeah, for example, I don't know. So you worked only in USA, and you, I mean, do you have any feelings about what, in which countries the situation is better? So is, for example, the percentage of women in IT is higher, or kind of some personal feeling?
So the company that I work for is actually Swedish. We just have a large base in the US, so I do travel to Sweden a lot, and like half people that work there are Swedish. My first employer in engineering is Red Hat, and my team is Czech, so they were based in the Czech Republic, and I got to embed for like 5 months total with them. So I've had work experience with different cultures. I found that working with other Czechs, it wasn't like a gender wasn't really a thing. It was just like more meritocracy, but also they didn't understand the importance of trying to get more women into like programming. They just, but they didn't really care that I was like, I didn't feel any prejudice about being a woman engineer there, so it was just like kind of matter of fact, which I can appreciate, but also kind of wish that they would embrace a wave of diversity or something like that. The Swedes, I think they are I feel like a lot more ahead than the U.S. in terms of like equality, because of the social system that they have there. But they're also like, why should we care? Because it's still a problem there in terms of women in tech, but I guess they just don't see it as a problem.
Yeah, well, I worked in Finland for 3 months, and I felt like my team is really happy that they have a woman in a team, because there are a lot of men, and yeah, so maybe in Europe it's, of course, there are still not a lot of women, but it's not as bad. At least I never notice any bad attitude or something like this.
I feel like it had like the tone has like shifted in Europe. Like when I started with like PyLadies like 6 years ago or so, it took a lot better in the U.S. than in various areas of Europe, and now it's just like a huge wave of embracing like PyLadies and other kind of women in technology efforts. So I think we're getting there. I know that there's another speaker.
Последний можно?
Yeah.
Okay, I came up with one more question. I think it's a tricky one, maybe, because I had lots of discussions with the organizers of Jungle Girls and Python Moscow. That's a community in Moscow of Python developers. So it's about PyLadies meetups and the increasing role of diversity here in conferences in Russia, because I talked to lots of organizers of programmer conferences here, and they all say that if we want to be a European conference, we should take care of the diversity and invite more women speakers and stuff, and But what if, and this is definitely happening, you have an event and you have to care about diversity, but your woman speaker is definitely worse than another speaker, a man, who can just bring in the topic and do it like brightly and stuff. Well, what should we do? Like, should we care more about the speech, the material, and like bright performance, or should we care more about diversity? I have some ideas about that, but I'd like to hear you. What should we do? Like, what should we do?
That's a good question. Years ago, I think I said that we know we've made it when there are shitty women developers. Like we can't like. There's going to be a variety of skill in speaking, and when you have all the variety for, I guess, women speakers, then that's a sign that you're doing pretty well in terms of like getting diverse speakers. However, if there's only like one woman that's like willing to speak and then she's crap, that's another issue. I think that I wouldn't push them away from speaking, but what I would do is effort and put effort towards the pipeline in terms of like hosting events on like how to give good talks or what makes good talks, and trying to get that pipeline of people proposing talks like a little bit more increased and a little bit more diverse, so that like you don't take her away from like giving the talks that she wants to give, but you also kind of alleviate yourself a bit by like padding like the pipeline of who can speak. So it does take more effort, but you have to, I guess, start earlier in terms of inspiring women to speak and giving them the time and holding hands a little bit. Yeah, exactly. Yeah. Yeah.
So, we are a bit on a schedule here, so right now what I want you to do is to, first of all, thank you for all your questions. It's like a time now to select a best and most engaged person.
Oh my goodness.
Well, it's subjective, so.
What, does this question count? Yeah. Let's see. I think I'd actually, I forget your name. I'm sorry. I didn't. Yeah. Irina? Okay, Irene. Thank you for asking the difficult questions.
You're so welcome.